Hello Legacy Sabers, Marsh here. So today we're going to look at how to graph an ellipse that is centered at the origin. You're going to want that Conics foldable once again in your backpack or in your notebook. So let's get started here. So you're going to go to the Ellipses tab to open up to there. We're just going to do one of the problems here because we are going to spend a couple of days on ellipses. So let's first talk about the parts of an ellipse. There's several key information pieces of an ellipse. First thing we want to talk about is, of course, the center of the ellipse. Kind of like the center of a circle, we have the center of the ellipse. Then we have what's known as a major axis. The major axis is the axis of the ellipse that is the larger of the two. Of course, then you have what's known as the minor axis, which is the shorter of the two. And if the major and the minor would be the same size, then we would have a circle. So the major axis is the longer side or the longer way of the ellipse, and the minor is the smaller side. Along the major axis, we have what's known as foci, the focus of them, and we also have what's known as vertices on each side as well. Probably asking, what is a foci? Well, ultimately, an ellipse is created by rotating around 2 points and the sum of the difference between the two. That is why the foci are generated on there. Then we also have what's known as co-vertices. So those are the vertices of the minor axis. Those are basically the outside dots, I guess if you want to call it, of the ellipse. I know, tons of information, tons of things. But the main things that you need to remember is the foci, the co-vertice, and the vertice, and the center. Once we get that information locked and loaded, we got this, okay? Now, there is a standard form of an ellipse. It looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. A has to be greater than b, and b has to be greater than 0. So a has to be the bigger guy. If that's the case, I have what's known as a horizontal major axis. It's going to look something like this guy. Notice it's longer left and right than up and down. And those A and those B's actually have a meaning to my equation. The A is how far my center is from my vertice. Okay, so we're going to make a note of that. A is center to vertex on both sides. B, of course, is the center to the co-vertex. So center to co-vertex. And then, of course, I did label what C is. Remember, C, these guys right here are my focus points, my foci, if you want to say two of them, which is my C value is center to focus. Now, you're probably saying, well, Marsh, there is no focus, no C in this equation. You're quite right. The point of the C's we will find using an related equation to mine. Now, this ellipse is very similar to a circle. The A tells us how far left and right we're doing. That's because it's under the X. And then the B tells you how far left, up, and down you're going to be going. So keep that in mind. Now, determine if your ellipse has a horizontal or vertical major axis. You're going to look and see which variables have the larger denominator. Then the equation would be, so if my major axis is horizontal, I'm going to have a underneath the larger denominator. If it's a vertical major axis, A will be under Y, because remember, A has to be the bigger denominator, or the bigger number. So basically, you're looking on who has the biggest denominator. That tells you which way your ellipse will be facing. Is it going to be a left and right bigger, or up and down bigger? Or is it going to be taller, or is it going to be a fatter ellipse, basically? If it is a vertical ellipse, same idea still looks. I'll just have a major axis that is vertical, a minor that is left and right, and then of course I'll have foci, my vertices, and my co-vertices all on there as well. So the parts of the ellipse look exactly the same no matter if it's flipped or not. Standard form of my vertical ellipse looks very similar to the left and right, except again we have our B and our A that are flipped. Okay. Formula for C. How do you find the foci from the equation? Well, to find the foci, or the foci, we're going to get a squared minus b squared equals c squared. So again, we're going to find our a, which is the center to the vertex, b, which is the center to the covertice, and then c will give us our center to our foci. Ultimately, each time we're going to want to find that information. Notice it is a subtraction, not plus. This is not the Pythagorean theorem that is working for us, okay? So keep in mind when we're solving it. Let's actually do a problem together, shall we? So we're going to want to graph this ellipse and identify its key characteristics. But first thing I notice is this is not equal to 1. And every single one of these equations that I've shown you are equal to 1, right? So I need to get this guy so it's equal to 1. So I'm going to divide by 25 over here, which if I do that, I can divide everybody by 25. So I'm going to get x squared over 1 plus y squared over 25 equals 1. Notice why I get 1 down here is because 25 divided by 25, right? So now I'm going to look at this equation. Who has more in the denominator? Y does, right? Y squared. So that means it is a vertical major axis that we have located here. This guy, since there's nothing in the x and y, he has a center of 0, 0. We're slowly getting you guys used to finding this. So what I'm going to do is I'm going to put that dot on my graph here. I'm going to mark it with a little c. So I notate that that's the center. Now, I want to find my A, B, and my C. So A is the bigger number. So I'm going to square root this number down here because it's A squared down there. So that's 5. B is the square root of the other number, which in this case is 1. And then I need to find C. Now remember, it was A squared minus B squared. So 25 minus 1, that's 24. So C would be the square root of 24. Or what would be 2 square roots of 6. Correct? That would also be 24. So let's find some more information. I'm vertical. Remember, A is your vertices from your center. So I'm going to go 5 up and down because that's going to give me my major axis. So 1, 2, 3, 4, 5. Mark that with a V here. Whoops. My pen decided to go a little wonky there again. All right, now I'm going to go 5 down. 1, 2, 3, 4, 5. Again, that's my V, marking it with my little V. So my vertices ordered pairs are 5, 0 and negative 5, 0. My co-vertices, remember that's your B value, so that's how far left and right I got to go. I gotta go 1 over and 1 over, and those are my co-vertices. I'm going to put CV beside them. And then I can actually draw in my dots. So there's my beautiful ellipse. I know, beautiful, right? My order pairs for my co-vertices, negative 1, 0 and 1, 0. Okay. Now, let's find our foci. My foci, same word, kind of like potato, potato. That is going to be from your center to your vertices center to foci, but it's going to be along your major axis. So I got to go 2 square roots of 6 up and down. Now you're probably thinking, well, Marsh, how do I know what 2 square roots of 6 is? Well, ultimately, we're going to need to find a decimal for that information. 2 square roots of 6 is approximately, I'll grab my calculator out here, 4.89, so just a little under 5. So I'm going to go up and down. 4.8. 1, 2, 3, 4. A little bit closer. So this would be right here. This would be my foci. Right there. So my ordered pairs, kind of a little off here. Oh, I just noticed. Why didn't you tell me something? I screwed up my vertices. Dag nabbit. This should be 0, 5 and 0, -5. Bad, Marsh, bad. Now, my foci. Ordered pairs, right? It's going to be 0, 2 square roots of 6 and 0, -2 square roots of 6. Not terrible once you find the A, the B, and the C. We are going to do another problem in class together to put one more example into your notes so that way you guys can ask me a question or two as well in class. Until then, I will see you later, Savers.